6 minutes ago, somewhere high in the Chilean mountains, a machine the size of a small car took another picture of the sky. Just one more image. But here the problem. For this machine, an image is never just an image. Sometimes it reveals an asteroid spinning, so fast it should tear itself apart. Sometimes it catches a star that may have died without exploding. Sometimes it uncovers a river of stars so enormous it challenges the scale of our own galaxy. And sometimes it finds something that does not belong to our solar system at all. Think about that. How many things have passed above us, hidden in plain sight without a single human being noticing? Because for the first time in history, we have built a machine that does not just look at the sky. It remembers it. And once the universe is given a memory, it stops hiding its secrets. It starts confessing them. This is the story of the Vera Rubin Observatory. And what it has already done in its earliest phase has led astronomers to say something extraordinary. This is not just a telescope. It is a live surveillance system for the universe. And the most shocking part, it has barely even begun. On June 30, 2026, after 25 years of construction, delays, testing, and quiet anticipation, the Vera Rubin Observatory officially began its real mission. Not a preview. Not a dry run. Not a demo. The real mission. A 10-year project called the Legacy Survey of Space and Time. That name sounds technical, but the idea is simple. Every 3 to 4 nights, Rubin photographs the entire visible southern sky. Not one galaxy. Not one star cluster. Not one beautiful patch of space. The entire sky. Then it compares each new image to the one that came before it. If a single point of light has moved, brightened, dimmed, appeared, or vanished, the system flags it instantly. And once the observatory reaches full speed, it generates around 7 million alerts every single night. 7 million. Every night. Let that sink in. This telescope is not taking static pictures of space. It is building a living record of change. It is turning the night sky into something dynamic, trackable, and impossible to ignore. And that is where everything changed. Now go back 1 year. June 23, 2025. That was the day the world got its first real glimpse of what Rubin could do. Using only about 10 hours of test observations collected across 7 nights, the observatory released a single composite image. And inside that one image were 10 million galaxies. Not stars. Galaxies. 10 million entire galaxies in one release. And somehow that was only the beginning. According to scientists, that breathtaking image represented just a tiny fraction of what Rubin is expected to collect across its full 10-year mission. The long-term goal. Roughly 20 billion galaxies. 20 billion. But as overwhelming as that number is, the real shock was not the count. It was what was hiding inside the data. Buried in those early images, astronomers found a previously uncatalogued stellar stream stretching an estimated 163,000 light-years away from the spiral galaxy Messier 61. That is a structure so large it rivals the width of the Milky Way itself. And that discovery forces an uncomfortable question. If something that enormous could sit in the sky unnoticed for so long, what else have we been missing? That is what makes Rubin dangerous in the best possible way. Hubble gave us stunning detail. James Webb gave us the deep infrared universe. But Rubin gives us something different. Rubin gives us change over time. It does not just photograph the universe. It watches the universe behave. And behavior always tells a deeper story than a single frozen frame ever can. Now we get to the object that made scientists stop, stare, and check their calculations twice. Its name is 2025 MN45. On paper it sounds ordinary. Just another asteroid in space. But once astronomers measured what it was doing, it became one of the strangest objects found in recent memory. This asteroid is about 710 meters across. That is enormous. And yet it completes one full rotation in just 1.88 minutes. Less than 2 minutes. To understand why that is so disturbing, you have to understand what scientists think most asteroids of this size actually are. They are often described as rubble piles, loose collections of rock and dust held together by weak gravity. A body like that should not survive such an extreme spin rate. It should break apart. It should shed material. It should destroy itself. But 2025 MN45 is still there. Still intact. Still spinning. Still refusing to behave the way physics says it probably should. So what is holding it together? One of the leading ideas is that this may not be an ordinary asteroid at all. It could be a fragment from the dense metallic core of a much larger planetary body, the shattered remains of an ancient world destroyed billions of years ago in a violent collision. If that idea is correct, then this is not just a fast rock. It may be a surviving piece of a dead planet. And the most astonishing part, this was not discovered during Rubin's mature, fully operational science phase. This came from early commissioning data. A warm-up. A systems check. And even during that stage, Rubin was already breaking records in asteroid science. Zoom out even further and the scale becomes absurd. In just a few weeks, Rubin identified more than 11,000 previously unknown asteroids. And projections suggest that in its first full year of operation, Rubin could discover around 1 million new asteroids. 1 million. That is roughly comparable to the total number humanity spent generations painstakingly cataloging over the last 2 centuries. What took us 200 years, Rubin may double in 1. This is not just observation. This is acceleration, but the next discovery is even more unsettling. Because this is not a story about something appearing in the sky. It is a story about something disappearing from it. Astronomers call it a failed supernova. Normally, when a massive star reaches the end of its life, it explodes outward in a spectacular supernova, a violent, brilliant event bright enough to briefly outshine entire galaxies. But a failed supernova does the opposite. Instead of exploding, the star collapses inward and may turn directly into a black hole. No flash. No warning. No cosmic fireworks. One moment the star is there. The next moment it is simply gone. For decades, this was mostly theoretical because it is incredibly hard to detect. It is easy to notice an explosion. It is much harder to notice an absence. And that is exactly where Rubin becomes extraordinary. Astronomers identified a possible candidate for this kind of event in the Andromeda galaxy, a star that may have quietly collapsed without ever putting on the dramatic display astronomers were expecting. If that result is confirmed, it would mean some of the universe's most massive stars may be dying in silence, creating black holes without announcing themselves. And if that is true, then there may be far more black holes scattered across the cosmos than we have ever counted. Rubin is uniquely suited to find these events because it is built to notice what changes, even when the change is subtle, quiet, or easy to miss. In one alert system test night alone, it generated 800,000 alerts. At full operating scale, that rises to roughly 7 million alerts every night. That means every moving object, every variable star, every transient flash, every disappearance, and every anomaly becomes part of a searchable stream. And once you start recording reality at that level of detail, you stop just finding rare events. You start uncovering hidden patterns in the universe itself, and then there is the part of this story that feels almost cinematic. In July 2025, astronomers announced an interstellar comet, an object that did not originate in our solar system at all. It came from somewhere else. Another star system. Another cosmic neighborhood. But when researchers later went back through Rubin's archived data, they found something surprising. Rubin had already captured images of it 10 full days earlier. 10 days. The object had been there the whole time, sitting quietly inside the data before anyone realized what they were looking at. Think about what that means. Sometimes the universe does send the signal. The problem is not that the signal never arrived. The problem is that we were not yet capable of catching it in time. Rubin changes that. For the first time, we have a system that does not just help us detect what is happening now. It gives us the ability to interrogate the recent past. When did this object first appear? How long was it visible? How many more visitors like it are already hiding in the data? Some scientists think Rubin could find only a handful of interstellar objects. Others think it could find hundreds. And that uncertainty is exactly what makes this moment so exciting. Because when experts give you a range that wide, it usually means one thing. We are entering a part of reality we have never explored properly before. But as dramatic as all of this is, the asteroids, the silent stellar deaths, the interstellar visitors, none of it is the observatory's deepest purpose. Because Rubin was truly built to chase something we cannot even see. Dark matter and dark energy. Everything visible in the universe, every star, planet, galaxy, and human being who has ever lived, makes up only a small fraction of what actually exists. The rest is hidden. And the observatory is named after the astronomer who helped prove that hidden universe was real, Vera Rubin. In the 1970s, Vera Rubin studied how galaxies rotate and found something deeply wrong with the numbers. Galaxies were spinning so fast that, based only on the visible matter inside them, they should have flown apart. But they did not. Something invisible had to be adding extra gravity. Something we could not see but whose effects were everywhere. That invisible mass became known as dark matter. And now, the observatory carrying her name is continuing the question she helped ask. What is really holding the universe together? Rubin's strategy is breathtaking in scale. By measuring the light and positions of billions of galaxies across enormous distances, astronomers can map how matter, including invisible matter, is distributed through the cosmos. Over time, Rubin is expected to measure the properties of billions of galaxies, helping scientists build one of the most detailed large-scale maps of the universe ever created. In other words, Rubin may help trace the hidden skeleton of reality. And then there is dark energy, the mysterious force that appears to be driving the accelerating expansion of the universe. Scientists still do not know what dark energy actually is. They do not know whether it is constant. They do not know whether it changes over time. But Rubin may help answer that too. By detecting enormous numbers of type Ia supernovae, astronomers can use them as cosmic measuring markers to track how expansion behaves across time. If Rubin reveals that dark energy is evolving instead of staying constant, that would not be a small update. That would be one of the biggest discoveries in the history of physics. It would force us to rethink how the universe works and possibly how it ends, so step back and look at the full picture. A machine opened its eye and almost immediately revealed 10 million galaxies in a single image. It uncovered a hidden river of stars stretching across intergalactic space. It found more than 11,000 previously unknown asteroids. It spotted one object spinning so fast it should not be able to hold itself together. It helped identify a star that may have died without exploding. And it quietly captured an interstellar visitor before the world even knew it had passed through our neighborhood. And now, for the next 10 years, this machine will continue scanning the sky night after night, recording millions of changes that human beings would never be able to track by eye. For thousands of years, humanity looked upward at the stars as if the sky were fixed. As if constellations were permanent. As if the universe was slow, silent, and still. But Vera Rubin Observatory has already exposed a brutal truth. The sky was never still. It was always changing. We just never had a machine capable of remembering what it looked like yesterday. So it could catch what changed today. Now we do. And that means the real question is no longer whether the universe is hiding things from us. The real question is, what will Rubin uncover in year 5? What will it uncover in year 10? And how much of what we think we understand about the cosmos is about to break? How many black holes were born in silence? How many interstellar objects have already slipped through our solar system unnoticed? How many giant structures are still waiting inside the dark, buried in data we have not searched yet? We are not just watching a telescope collect information anymore. We are watching the universe get caught in the act of changing. And for the first time in human history, the sky may finally be opening its own file. If stories like this pull you in, the kind that quietly destroy what we thought we understood about reality, then subscribe. Because Vera Rubin Observatory is only getting started, and over the next 10 years it may produce some of the most important discoveries in modern astronomy. And tell me in the comments, what shocked you most? The asteroid that should not exist the way it does? The star that may have died in silence? Or the interstellar visitor that slipped past us for 10 days before anyone noticed?